All right, so this is another classic kind of problem. I want to find the dimensions of the rectangle. So the rectangle that I'm talking about here is this blue rectangle I've drawn that's inscribed. So it's underneath the parabola. So the corners of the rectangle touch the parabola and are underneath, so they do not go as far as the x-intercepts of the parabola. So you know the x-intercepts of this parabola would be 2 and -2. So those x distances, right, they'll be the same distance here to here. This width of the rectangle does not go all the way to 2 and -2. So let's find the dimensions that give this rectangle the largest area. The largest area. All right, so let's find the area of our rectangle. So the area of the rectangle is width times height. So the width of my rectangle goes all the way across here. So the width of my rectangle would be 2x. The height of my rectangle would be here to here. So the height of the rectangle will be a y value, right? F of x. F of x. And I know that f of x is equal to 4 minus x squared. I'm going to multiply this out because I can see that's going to be easier than doing product rule. I'm going to take the derivative, so I get 8 minus 6x squared, setting that equal to 0. I get x squared is equal to 8 over 6, or 4/3. So x is equal to plus or minus 2 over root 3. So x equaling 2 over root 3 is the one of those distances. So let's talk about what the dimensions of the whole rectangle would be. So the width of the rectangle would be 2 root 3's, right? Because I'd have 2 of those x's, so 2 times. The height of my rectangle would be the y value, so that would be 4 minus 4/3. That's me plugging in this 4/3 in for the x squared. All right, let's continue on with this next one, another classic problem. So I've got a box with a square base. We've done ones like this before, square base, an open top, and you don't know what the height is. So you have to just make it some unknown height. You cannot make it a cube. And it's supposed to have a volume of 50. Volume of 50 cubic. So 50 is the volume. And that's going to be x squared h. All right, so the cost of the material, that's what I want to minimize. So cost is going to be what I'm going to take the derivative of and set equal to 0 after I finish everything off. All right, so let's talk about the cost for the sides. The cost for the sides is $3 per square inch. So $3 times the area of all of the sides. So I have 4 sides of area xh. So that's $3 times the area of the sides, plus the cost for the bottom is $5, and the area of the bottom is x squared. So I'm going to take this and I'm going to solve it for h. So this cost equation here, I have 12x, and instead of h, I'm going to be putting in 50 over x squared, and this is 5x squared. So I'm going to fix this up so that I have a nicer thing to take the derivative of. So here I get 600 over x plus 5x squared. So this is what I'm going to take the derivative of. So that gives me negative 600 over x squared plus 10x, setting that equal to 0. So I get 10x equals 600 over x squared. X cubed equals 60 by cross multiplying. So x is equal to the cube root of 60. So that's the x, that's the width of the bases, and so now use this to find out what the height is. So in for x, I'm putting 60 to the 1/3, so I get 60 to the 2/3 for the height.